Hello everyone, this is Mohsen Seraj. I'm a Senior Application Engineer for Ansys CFD at Ozen Engineering. In this video, I just want to walk you through the different ways that we can work on the meshing in refine mode in Ansys Discovery. In the refine mode, basically we use fluent meshing, and also for the solution we use fluent solver for a CFD simulation in Ansys Discovery in refine mode. So basically it is like using Fluent for meshing and solution in Ansys Discovery. So the 30 new features in Ansys Discovery in refine mode is that first of all we can use GPU solver that we call it live GPU, live GX. And another things is that besides tetrahedral meshing, we can have polyhedral elements, and we don't need remeshing the model when we solving the model. This model is same as the model that we used it before for explorer mode, meshing in explorer mode. That it was the first part of the blog that I had for Ansys Discovery meshing. I just subdivided this room into the different parts, and each portion, as you can see, and also I use transparency for the portion of the room that it is near the server and the fan, and also on this corner. And I'm going to use the local meshing in those two areas. So let's start working on the meshing and see what we can do. For meshing and size control that we have for in the refine mode, first of all, for global fidelity, we have different options here compared to the explorer mode. These are the options that we have similar to what we have in fluent meshing for the curvature, proximity, and curvature and proximity together, or if we want to have fixed size. And another things, as I told you before, we can use local fidelity, that we can assign just the specific size for the meshing to the part of the domain. That here usually we don't have it in available in explorer mode unless we're using beta features in Ansys 2024. And another good update is that we don't need to really solve the model if we want to see the mesh. Okay, let's back to the model. Again, we can use the slide bar for changing the fidelity or mesh size here, and also we can work on the global fidelity, okay, curvature, proximity, or whatever, or local fidelity. So it depends what we have. Let's first mesh the domain. As you see that the meshing start. So one thing is that here we have the mesh information here. As you can see that almost 14,000 elements and about 5,500 nodes. So we have the information about the nodes as element readily given, and we haven't solved the model yet. Let's increase the fidelity to see that what we can have. And the meshing started. If I check the number of the elements, from 13,000 increased to 20,000 elements, and from 5,500 to almost 7,400 nodes. Go to the high fidelity by the slide bar, remeshing the model, and with the high fidelity the number of elements sharply increase to almost 390,000 elements, and where the nodes it is above 100,000 nodes. So this is the way, this is one way that we can change the meshing fidelity, that in this way the adjustment to the meshing size or the refinement applied to everywhere into the domain. I solved the model for these different global fidelity that I adjusted it with the fidelity slide bar. Let's check the effect of the mesh size on our results. First of all, this is the answer from Explorer mode. That you remember that previous blog that the magnitude of the velocities is like 0.85 to maximum 0.93. It jumped to 1.9 for refine mode. So you can see that how much mesh can affect our results. So if you are at the very beginning of the if you are at the very beginning of the development of a product, Explorer mode can quickly give you the answer. But if you need higher level of the confidence on your results, for sure you have to use Ansys Discovery in refine mode. uh, for the temperature, again you can see that we're having about 20.5 up to 22 degree Celsius for the max temperature from the Explorer mode. It gives me below 20, and for the highest fidelity, global fidelity, it gives me again back to the answer back to 22 degree. Okay, let's see what's happened if I work on these the schemes for the global fidelity. So instead of using the default value, let's use the curvature and proximity. But okay, the mesh is done for curvature, capturing curvature and proximity, and these are the information for the mesh. I solved the model with the mesh with curvature and proximity. Let's check if there is any effect on the answers. Not really for the velocity. For temperature, again the same. Pressure drop, almost the same. Volume flow rate, not really. And the reason is that the initial mesh with global fidelity, that automatically sizing the meshing is good enough for capturing the curvature and features and proximity of the features inside the domain. We can check the mesh specifically inside the domain by sectioning it. We can define a plane for the section and then see interior meshing on the of the domain, specifically around the solid box and or around the solid cylinder that we have for the inside fan. Let's check the mesh interior to the domain. If we want to see the mesh inside the domain, we can use the here a section plane that it could gives us the mesh inside the domain, for example around the here around the solid box. Okay, and around the cylinder for the inside fan, also here for example for this wall fan. So we can see also the mesh inside that by sectioning the mesh from here. Now let's use local fidelity. I can assign the mesh to the specific part. Okay, as you can see, for example here, here, or here. I choose this part, and I can assign different types of the meshing, different size of the meshing. Say that, for example, I assign 200 millimeter. As you can see that now we have a new size for the meshing, that it is only just applied locally to this space. I can also use that corner and apply local fidelity, local size of 100 millimeter. And let's see what's happened. Okay, let's remesh that. We have very high fidelity. We can decrease that. Okay, if I decrease it maybe it is easier. Now it is better visualize the different size of the elements for the mesh in this corner and in here. Okay, let's check the mesh inside. I section the domain. We can see that have different sizes we have in this corner and on the other side. If I okay, and all these meshes, there's a triangular meshing with also a boundary layer at the walls. If I move this section plane until getting to the solid wall, yeah, you can, and the solid box, you can see that this the discretization for the solid box and the volume around it, how much different sizes we have. Moving toward the, you see that, and when we getting to the, yeah, you can see again different size of the discretization. So basically we refine the mesh here in this area, but on the other part of the domain next to that we don't have such local refinement, and that's why you see that very larger size for the triangular element and tetrahedral element here. Number of elements from the very low fidelity that we had, it used to be something like about, okay, let me share it here. It used to be like 13,000, 14,000 elements and 5,500 nodes. Now with these two local sizes, local adjustment that we have, it increased to from 13,000, 14,000 increased to 54,000 elements, and the nodes from 5,500 increased to almost 16,000. So you can see that the effect. So whenever we have a region of interest, we can locally apply the the mesh the mesh refinement there. Another option in refine mode is that if we come here to the solution options, and if we check the specified meshing method in this option, so far we just use tetrahedral meshing. We have another option for polyhedral meshing. Let's try it. So this is also only in the refine mode for polyhedral meshing. Okay, let's mesh it. The meshing is undergoing, as you can see from this moving white spot, white dot. And polyhedral mesh is also a native mesh in Fluent Mesher. So I'll be back after the meshing is finished. Okay, meshing is done. As you can see, it is not anymore only triangular. Let's check the mesh. Okay, for example, if you want to see, okay, you can see the mesh at the corner, how it is more tense compared to the mesh around it, and even the mesh inside the solid box, it is much better than before, and also the boundary layer around the mesh. Okay, if we want to check the number of the elements and nodes of triangular meshing, for triangular meshing, it is 195,000 almost elements and almost 46,000 nodes for triangular meshing. Compare this again with almost 30,000 mesh elements and almost 10,000. So you can see that uh, not only better meshing that we have, meshing quality that we have here, even we have much reduced number of the mesh elements here, that also can save the time in refine mode. I solved the model with polyhedral mesh. For sure the solution time it is much lower. If checked, we see the results, the effect of the meshing on the results, same velocity for tetrahedral and for polyhedral compared to much lower number of the mesh elements and also solution time. A little bit decrease into the temperature, as you can see here, and also we can check the effect of that on the other parameters like pressure drop or other things. We can have mesh information and mesh quality in another way, not only for the mesh statistics here from monitors. At the bottom of the list, we have two items for mesh statistics, similar to what we have information about mesh elements and nodes, and one more item which is here, mesh quality. If I choose, for example, whatever the mesh in the domain, you can see here that the mesh first of all, the mesh quality could be not only mesh quality, different items similar what we have in the Fluent meshing list. For example, orthogonality, skewness, aspect ratio, or whatever. If I check, say that aspect ratio, and press the green button, you can see that here we have aspect ratio of 4.31, and it is an average for the whole domain. We can have maximum. Okay, maximum it is this minimum 1.38 and maximum it is 23.9. We can also work on the say that, for example, orthogonality, quality, or whatever that we have. So this is also options that only we have in refined mode. Okay, we get to the end of this video. I hope that now by end of that you can know what are options that we have for the meshing for the refine mode. Specifically at the simulation section, we have these tabs for the global, local, size preview, and also here for the simulation option that we can choose we can choose either tetrahedral or polyhedral. Tetrahedral is the default option. And one more thing is here that for solving we used to have only CPU available for the solution in refine mode. Now GPU computation is also available, that we call it Fluent Live GX Solver. We can use CPU if we want also. Thank you very much.